I've been using this one ingredient to turn food waste into beautiful garden soil for the past 5 years, and it still shocks me when I see those leftover scrambled eggs that my 3-year-old threw on the floor seemingly melt into the earth. In this video, I want to share with you, 1, how to make this powerful ingredient, 2, how I use it to turn food waste into soil, and 3, if you already know how to do this, I've got a few extra goodies toward the end of this video that you might find fascinating, so stick around. But first, welcome back to the channel. If you're new here, I am Taylor, and I help gardeners explore sustainable and regenerative growing techniques that not only bless the soil, bless the environment, but also bless the grower. And part of the way that we do that on this channel is by providing free resources that help you along your way. So we've got a couple that we want to share for this video, so those will be linked in the description, or you can scan the QR code on the screen. If you're watching this video, you're going to want those to help you get started. So what is this secret ingredient? Well, it's really not very secret. In fact, it's been used in some form for hundreds, maybe thousands of years, especially by natural farmers across the globe. And this exact technique may be a little bit more recently discovered, but it all comes down to lactic acid bacteria. And for those of you who don't care so much about the science here, that's totally fair. I'm going to give you the rundown of how this works and how to do it, and then we'll get into why it works. Starting at the very beginning, we need to make our lactic acid bacteria, or LAB for short. And this is one of the 9 core inputs used in Korean natural farming, and it's one of the easiest to make. As I mentioned before, if you'd like, you can download my very simple, easy to use printable recipe for this. Scan the QR code or hit the link in the description and it'll give you that if you want to follow along. To make this, you will need a starchy grain such as rice, barley, oats, millet, whatever you can get your hands on. And then you'll just need dechlorinated water. And to start the process, that is it. What you're going to do is you're going to take your starchy grain and rinse the starch off of it. And as far as amounts go here, I usually do equal parts grain to water by volume. So 1 cup of rice in this case, plus 1 cup of water. And then I'm just rubbing the grain in the water so that the starch comes off and makes the water really cloudy. You want to rinse your grain for a while here, maybe a minute or so, and then pour it off into another container. Something glass or ceramic or stainless steel is going to work best. And what you are essentially getting is actually 2 things. First, you're collecting the starch from the grain in the water. And second, you're getting some dormant lactic acid bacteria on the surface of the grain. Now, once the LABs touch the water, they'll start waking up. Technically, you've collected LAB in a jar here, but they're not really active, and they're still pretty low in numbers. However, if we just let this jar of starch water sit on the counter, those LABs will start swimming around, consuming the starches for energy, and they'll multiply. You want to just cover the top with either a breathable lid or a loose-fitting lid so that the bugs and dust doesn't get in there. Just like waking up yeast before making bread, you kind of got to give these guys the chance to wake up. And this takes a few days to fully happen. A sign that their activity is in a good place is when it starts to smell a little sweet and sour, and you might even see a thin white film on the surface of the jar of water. If you notice any black or colorful mold, that means that your ferment got contaminated by something and you're going to want to start over. After a few days, it should be ready to move on to stage 2, which is where we give the lactic acid bacteria a new food source, which is milk. Now, I always get questions about this, so I'll just address it right here. Yes, it has to be animal milk. It can't be a nut milk or oat milk or any other alternative milk. The lactose in the milk is what we're after, and that's what the LABs are going to feed on and diversify themselves with. So go ahead and pour your LAB culture into your milk. Exact amounts honestly don't really matter here. If you just mix a little bit of LAB, it'll take a little bit longer, and if you add a lot, it'll take a shorter amount of time. I usually eyeball it and go for around 1.5 cups of fermented starch water per gallon of milk. And then you just let that sit, and it's the same thing as before. Wait a few days. This time it'll be pretty obvious when it's ready to use because the LABs in the starch water are going to consume the lactose in the milk, poop out lactic acid, which is going to lower the pH of the milk and cause the milk to curdle. Yummy. You want to give this all the time it needs to fully happen. You'll see the milk curds start to solidify and clear liquid will start to generate around the curds. And then after a few days, the curds will have fully separated from the whey, making 3 layers within the container. The top layer where the curds are floating, the middle yellow liquid layer, and the small amount of sediment sitting on the bottom of the container. Now all you have to do is gently remove the curds, strain out the whey, And that is your lactic acid bacteria that you can use to turn food waste into soil. Now this stuff can go in the fridge, sealed up, and last for up to a year or maybe even longer. But if you'd like to store it at room temperature like this, you can add a bunch of brown sugar, approximately equal parts LAB to sugar by weight. And this will create a very syrupy environment that keeps the LAB locked up and dormant until they are reintroduced to a new environment, which is exactly what we do when we use them to ferment our food scraps. And yes, you heard that correctly. This LAB is what we're going to use to pre-ferment and prepare our food scraps to become soil. To do this, we need three things: a fermentation bucket, our LAB, and our food scraps. Pretty simple. For the fermentation bucket, you can make one of these really easily with just two 5-gallon buckets, a drill, and a sealable lid like this. Drill holes in the bottom of one of these buckets. These can be 1/4 inch wide holes, but probably not much larger than that. And then you're just gonna put that bucket on top of the other bucket. And the reason that you need the holes in the bottom of the top bucket is because the food scraps are gonna go in there, and as they ferment, they will accumulate moisture. And we don't want that moisture to build up in the bucket. We wanna drain it off so that we can easily pour it off from the bottom bucket. This is the only finicky part of the process here. Managing the moisture content of the bin is key, and we'll get into that later on in this video. So we've got our fermentation bucket, we've got our food scraps, and now we just need to dilute our LAB a little bit before spraying it on our food scraps. You can spray it undiluted if you want, but I like to water it down to make it go a little bit further. You can mix it 1-to-1 in dechlorinated water and keep the spray bottle in the fridge. To use this, you're just trying to get the food scraps covered in the LAB. They don't really need tons of it, just enough so that every part of your food scraps are covered. If you can, you may want to chop up food scraps into smaller pieces if you're able, but it's not completely necessary. I've done this with a whole chicken thigh that I left in the fridge too long, and it eventually made soil. So anything is possible, you just have to believe. Once your food scraps are covered in the LAB culture, you want to press them down into the bucket. For this, you can use a potato masher or a tamper of some kind. You can even use a gloved hand or a bare hand if you have no fear. Just make sure to wash your hands well after handling raw meat and rotten food. And I should say, if you find a Tupperware in the back of the fridge and it's growing a planet's worth of blue-green mold, you probably shouldn't toss this in the Bokashi bin, because the molds are going to interfere with the LAB and might outcompete them and compromise your bin. A few colorful spots here and there are probably fine. Once you've pressed the LAB-coated food scraps into the bucket, seal up the top so that the scents stay locked in and the fruit flies stay out. And then you can just fill the bucket using the same process over and over and over again, tamping down the food scraps and pouring off the leachate food juices as you go. If you want to, you can pour the Bokashi juice onto garden beds with no plants in the ground. You can pour it onto your compost pile. Wouldn't really recommend spraying it on your plants, even diluted, because it's sort of a gradually accumulated microbial soup, which means that those microbes go anaerobic pretty fast. But it's totally fine to pour where you're gonna plant later on, or like I said, on the compost pile. And once the bucket has filled up to the brim with food scraps, you're gonna want to seal it and let it fully ferment for 2 weeks. And that's gonna allow the lactic acid bacteria the chance to fully acidify the food scraps and culture them really good, get them ready to turn into soil. And by the way, you can totally add other things to the bin, like nitrogen-rich plant debris, comfrey leaves, crop residue, grass clippings. All of that is actually great to ferment because it preserves all of the nutrients so that they can be used as a source of nitrogen in a compost pile. After those 2 weeks are over, you can bury these scraps in a garden bed or, like I said, in a compost pile, and then make sure that they're covered with soil. Over the next month, the food scraps will slowly decompose and turn into nutrient-rich soil, pretty much disappearing and leaving behind a few biological remnants. They're also really good for your soil. You can bury these pretty much anywhere, just keep them maybe away from where your dog likes to dig. Animals are not going to be particularly attracted to these buried food scraps because of their acidic quality, so you don't need to worry about them digging them up. That said, it's probably not best to leave them out on the soil surface. Dig down a little bit and let them decompose in peace, at least a few inches down or even deeper. As I just mentioned, if you're using these in a compost pile, you can treat them as a source of nitrogen. If you're lacking nitrogen to make a hot compost pile, Bokashi fermented food scraps are a great way to give your pile that nitrogen boost to get it to heat up. And if you want to take this whole process a step further and use your LAB to make a fully shelf-stable, versatile, and microbially diverse bran. We'll go into that in the last part of this video. But for now, let's walk through why this works in the first place. We're culturing food scraps with LAB. Well, why does this work exactly? And if this is the first time that you've ever heard about LAB, or maybe the first time that you've spent so much time thinking about it, you might not realize that lactic acid bacteria is actually way more common than you think. If you've ever eaten yogurt, cheese, sauerkraut, kimchi, sourdough bread, or even something as common as Tabasco hot sauce, you've either consumed lactic acid bacteria directly or have at least benefited from it. In fact, our guts store lactic acid bacteria to help us break down and digest fibers, plants, and lactose. And believe it or not, this is a tiny list of all of the places that lactic acid bacteria can be found. It's on fruits and vegetables, grains and leaves. It's in the soil naturally, it's floating through the air, and more than likely, whether you like it or not, lactic acid bacteria are on your body right now, which is a good thing because that actually keeps your skin slightly acidic so that molds don't start growing in your armpits and between your toes. If there is mold growing in your armpits or between your toes, please get that checked out. Now, to cover my bases, I will clarify and say that when I refer to lactic acid bacteria, I'm using an umbrella term to refer to the order Lactobacillus, which I'm probably mispronouncing. But this houses 25 genera, over 400 species, and likely thousands of subspecies and strains, each of which is uniquely responsible for various roles in the microscopic world. But what does that have to do with turning your food into soil, you might ask? To answer this, I'll start by going over what would happen ordinarily if we just buried food scraps directly into the soil without taking them through this LAB fermentation process. The first thing that would happen, depending on where you live, is that animals would be attracted to the food that you just buried. Raccoons and rats, if you're in a suburban or urban environment, maybe other larger scavengers if you're out in the country a bit. And regardless of your location, flies would be a-swarming. These food scraps would act as a bit of a homing beacon for pests. Not the ideal. The reason that they don't go in for Bokashi food scraps, as I mentioned earlier, is that the LAB culture acidifies the food scraps, making them far less palatable for wild animals. Another thing that would happen if you were to just bury raw meat in the ground is that it would start to release ammonia and methane gas into the atmosphere, which would not smell great, and also would result in a slight loss of nutrients that could otherwise have been utilized by soil microbes. With Bokashi food waste, the organic matter is in a much more stable place from an acidity and microbial perspective. That nitrogen locked up in the food waste stays in the soil because it's been processed by the lactic acid so that it doesn't off-gas. The other thing that would happen with untreated food scraps in the garden is that they would break down very slowly and probably unevenly. The meat scraps and cheese would break down way later than the veggie peels, and you'd probably be left with decomposing, smelly food in your garden for months. With Bokashi, we've compressed that timeline into like a quarter of the time that it would take on its own. And that's really what Bokashi is doing. We're taking what nature does on its own, removing certain parts of the process, and then speeding up the beneficial parts. Lactic acid bacteria is going to help decompose organic matter in the wild. Other microbes are also going to go to work. With Bokashi, we're removing the competitors, giving LAB the ideal environment to do its part, and then introducing the organic material to the soil so that it can reimpart its nutrients. But how does that happen exactly? Well, the moment our fermented food scraps hit the soil, acid-tolerant bacteria and fungi in the soil are going to wake up, and they're going to start consuming the lactic and acetic acids directly as food. Within a few days, they'll begin to raise the pH, breaking down the organic matter and releasing carbon dioxide and heat as they respirate. Once the acidity has dropped a bit, other microorganisms such as actinomycetes, saprophytic fungi, and nitrifying bacteria are going to join the party. All of these are basically breaking down the materials into simple sugars, amino acids, and organic acids further. And again, this would all happen on its own under ordinary circumstances if food waste was just buried in the soil. It's just that we're skipping the line with Bokashi, so to speak, and avoiding the messy process that gets the organic material ready for decomposition. The result is microbially rich humus that's full of organic carbon compounds, stable nutrients in plant-available and microbe-available forms, improved soil texture, which helps with water carrying capacity, and a surge of microbial diversity in the soil or compost. And on top of all of that, you get to feel good about keeping food waste out of the landfills, which we are frighteningly and increasingly numb to. We really do need more solutions like this that replace our bad habits of seeing anything that's not immediately usable as waste. It's a really, really long shot, but it would be incredible to see more people wake up to the missed opportunity there to actually use your food waste to build lasting fertility in the soil. What if bokashi became a normal part of our culture? We're probably a very long ways away from that, but it starts with each of us leading the way. Okay, let's talk about next steps for our bokashi. I should say at this point in the video that in case you were unaware, you are more than able to purchase your own bokashi microbe spray from a number of companies. I'll link to one in particular in the description if you'd like to get started ASAP without going through the trouble of making your own LAB. They also have shelf-stable Bokashi bran, which is an inoculated rice or wheat bran using the common culture EM1, which stands for Effective Microorganisms 1. And they can also get you set up with bokashi bins and other stuff to get you started. However, if you would like to make your own bran, that is what this part of the video is going to be for. And I'll just briefly go over why you might want to do this by highlighting a few reasons. Number one, when you inoculate a bran material with LAB, it becomes a much more stable form of the culture and can last years or more if properly stored. So you can make huge batches all at once and then have a lot on hand ready to use when you need it. Two, bran is going to help manage moisture levels in your bokashi bucket a bit better. It acts the same as the LAB spray, but it also absorbs moisture from the food scraps and helps balance out the environment for fermentation. And three, this bran can be used for other purposes than just bokashi. You can use it directly on your soil, in your worm bins, in your livestock feed, pretty much anywhere in your garden as a way to increase microbial diversity in your garden. And then the last main reason for making a bokashi bran is that you actually get the opportunity to create an even more microbially diverse finished product, which, you know, sometimes the term diversity or microbial diversity gets used a lot without explaining it too much. And I won't go all the way into why we want microbial diversity, but in essence, the more types of good bacteria and fungi we can have in our gardens, in our lives, the better chance that we have to be able to adapt to environmental disturbances. More diversity grants extra resilience to our gardens. It gives them resources to utilize when temperatures fluctuate, when rainfall is minimal or excessive, when soil is sketchy, when pathogens risk creeping in, when pests are attacking. Microbes are the backbone of the garden in so many ways, and we want a wide net spread so that we can handle the diverse situations that arise. For making your bran, you really only need LAB and a wheat bran or rice bran. And then there are probably other things that you could use to sub in. I'm considering experimenting with cutting the bran with sawdust to see if I can stretch it a bit further. If you're not sure where to find wheat bran, you can go to your local farm supply store or feed store, and they should either be able to supply you or point you in the right direction. You can also use Azure Standard, which is a great resource for all kinds of things, one of which is organic wheat bran. This stuff that I'm using here is currently $12.50 for a 25-pound bag. So I will say I'm going to try out the dark wheat bran next time. It's a little bit more expensive, but I've made bokashi bran out of this stuff a few times now, and there are a few problems that I've had with it. Still results in a great product, but it's just not quite the ideal, which I'll get into why in a little bit. The basic recipe here is 1 part LAB that has had sugar added, equal parts weight to the LAB, and then 10 parts water, dechlorinated as always. As far as exact amounts of liquid to bran, I can't really quite help there because everyone's bran is going to be different. You're just going to have to trial it out for yourself. What you're looking to do is saturate your bran with the LAB water solution so that it's just damp but not sopping wet. Just like if you're making compost, damp, not wet. Now, before we do this, I'm going to show you a few other things that we can add to our liquid inoculant at this point to culture our wheat bran. And those ingredients are fermented plant juice, fermented fish amino acids, azomite, and sea salt. Allow me to explain. While lactic acid bacteria contains tons of helpful microbes, I'm always looking for ways to maximize the benefits of my inputs, especially when they don't take that much additional effort. So I'll say here that if you don't have any of these things on hand, there's no need to go and get them or make them unless you want to. I just want to showcase how you can use these. For the ratio here, I'm using the ratio here on screen. For this batch of liquid inoculum, I'm using about 5 liters of water or around 5 quarts. And then to that, I'm measuring out my other ingredients. I like to use a scale because it's a bit easier for me and a little bit more precise, but you don't have to be this precise if you don't want to. First, I'm adding my LAB. about 250 grams or about 250 milliliters. Then I'm just adding my fermented plant juice, about 125 grams, and then 125 grams of fermented fish amino acids. Here I had to scrape the jar a bit because I was running out, so I didn't get to quite the full amount, which is okay. And then I've got my sea salt and my azomite, and for those I'm adding 13 grams of sea salt and 31 grams of azomite. Then I whisk this up really good to make sure that it's all combined, and you might want to let this sit for a little while to let the sea salt and the azomite sort of dissolve, but I didn't. That's okay. And then I've got my wheat bran ready to be hydrated. And for this batch, I added my wheat bran to this big bowl and then just poured all of my liquid nutrients in. Not the ideal way to go about that, especially if you don't have any more wheat bran. Luckily I did, so I added more wheat bran until the moisture levels were about right, or I felt like it was good at least. And that said, in retrospect, for this batch of bran, it may have been a tad oversaturated, just barely. You can see that when I squeeze the bran hard in my hands, that a small amount of moisture comes out. That's kind of an ideal look. Once the bran is saturated, it's time to let it ferment. And the way that this works is that we want it to ferment in an environment that lacks oxygen, because that's where the LABs are going to optimally feed on the carbohydrates and the proteins in the bran. The way I accomplish this is by bagging it up in garbage bags and then forcing the air out so that it's sealed tight. If you had a vacuum sealer, you could use that for this part of the process, I guess. Although you probably don't want to seal it completely airtight because those bags are going to fill up with carbon dioxide as the LABs consume the carbohydrates in the bran. I like to double bag it for this very reason, in case the inner bag pops or breaks or something. I let this sit for a few weeks to fully inoculate. In warm weather, this happens a bit faster, but 1 to 2 weeks is about how long you want to wait. I waited 2 weeks and sadly, something happened. And to tell you the truth, I'm not exactly sure what exactly happened. I left my Bokashi bran behind the shed, and I think that whereas I thought my bucket was sheltered from the small amount of rain that we had, in reality, it appeared not to be. So I'm pretty sure some rainwater got in there. Also, the inner bag ruptured, which caused some seepage. Whatever happened, I found my bucket with a bit of excess moisture soaking the plastic bags, and when I removed the bran from the bags, it was quite soppy. And the next step here is to dehydrate the Bokashi bran so that the LABs go dormant again, and that's what helps this stuff keep indefinitely. But rather than throw this stuff out and start again, I decided to give it the old smell check, and I'd say it passed with flying colors. Smells sweet, pickly, and citrusy, like grapefruit almost, and it had no foul odors whatsoever. Not only that, but it passed the sight test in that it didn't have any colorful molds growing on it, indicating that the LABs had taken hold of the bran substrate and properly established themselves. However, the bran was still pretty soaked, so it took a while for this to dehydrate. Usually this takes place over the course of a week or even a little less, but this stuff took nearly 2 weeks to dehydrate fully. With this particular bran, and I alluded to this earlier, I find that it clumps pretty easily, which is not ideal. You really want it to sort of stay siftable. 1 week into the dehydration process, I scraped it up a bit off the kiddie pool that I'm drying it in, and I put it in a blender to break up the clumps. This took a little while, but I'm glad I did it because in the past I've been left with hard clumps that are difficult to break up, and this just makes the product a bit more usable. In the future, like I said, I'm gonna experiment with a dark wheat bran that has a bigger texture, and I think that that'll solve the problem. And so to conclude this section of the video, I'll explain a tiny bit more about what is actually happening here when we get the LAB onto this new substrate. You might remember from earlier in the video, I explained that the starch water that we wash off the grains contains newly awakened LAB. But letting it feed on the carbohydrates in the grain starch allows them to go into a state of activity, and it helps them diversify a bit. Then when we feed them to milk, they diversify further because they need to bring in new players to the team so they can digest the lactose in the milk. And this is just part of the way that microbes work. They diversify when the situation calls for it. Microbes are able to adapt to their environment, especially when gradually coerced to do so, which is what happens again when we feed them a new food source, in this case, wheat bran. Now, the fermented plant juice and fermented fish amino acids also carry their own unique lactic acid bacteria, as well as other decomposer microbes and enzymes that further round out the diversity of the culture. And the azomite and sea salt supply these microbes with even more food to process and adapt to. And if you'd like to learn how to make your own fermented plant juice and fish amino acids, you can check out this video for that. So with all of these ingredients mixed together, cultured, and then dehydrated, We sort of have the ultimate Bokashi bran that can be used, yes, to ferment food scraps, but also as a soil conditioner, as a compost pile activator, as chicken feed, as a worm bin addition in small amounts. I've even heard about people replacing their cat litter with Bokashi bran, although you might want to run some trials and slowly integrate the bran if you're going to do that. Cats can be pretty particular about their potty habits, in my experience. Now, as extensive as that process was, what if I told you that there was more? You probably wouldn't be surprised, because that is kind of our thing on this channel. But believe it or not, I think that we have other options for fermenting our food scraps than just homemade Bokashi bran, which I love using and will continue to use. It's just nice to have options. So, options. I actually got curious about this when one of you commented on a Bokashi video that we made last year, where we experimented with various ways to decompose Bokashi fermented food scraps, suggesting that I experiment using indigenous microorganisms to try to decompose finished Bokashi food scraps. Shout out at CrackDavidson1. That actually got me thinking, I wonder if I could use other cultures than just LAB or EM1 to ferment my food scraps. So I ran a little trial, and that trial included 4 different cultures to ferment food scraps in 4 separate Bokashi buckets. I used a store-bought EM1, a homemade LAB spray, my homemade shelf-stable Jadon microbial solution, and IMO4. And if you're new to these last 2, in short, Jadon microbial solution and indigenous microorganisms stage 4 refer to 2 ways that you can culture indigenous microbes from your local environment. And we've got lots of videos on both of those that we'll leave links to in this description. But essentially, I wonder if the lactic acid bacteria and other facultative anaerobes found in JMS and IMO might be able to preserve and ferment my food scraps prior to composting or burying and creating garden soil. After filling up 4 buckets and letting them ferment for a good long while, I finally got around to burying these food scraps in some less than ideal soil. There were definitely signs of life in the soil, but a lot of it was just pretty compact. I haven't had the chance to check on these since burying the contents, but my hunch is that the JMS and IMO got the job done just as well, if not better, than the LAB and EM1 sprays. And yes, ordinarily the microbial diversity that we're selecting for in JMS and IMO is largely aerobic, but with the quasi-anaerobic conditions of Bokashi fermentation, I think that the cultures in JMS and IMO adapt and diversify in their own way. Now, does this mean that I don't have any use for my Bokashi brand anymore? Not exactly. I still like how easy it is to make this stuff, and I can always give it away as gifts to my friends and relatives who want to try it for themselves. This Bokashi brand will work in any context, whereas dry JMS and IMO4 technically would work for anyone, but they're also technically made strictly for my exact growing space. Anyway, I hope that that was informative to y'all, and more importantly, empowering. It doesn't have to be as complicated as I just made it. You can literally just buy some bran and a bucket online and get started right away. That's how I first got started, and I super appreciated the ability to do that. If you want to take it a step further, you can make some LAB and use that. If you want to take it a step further past that, you can make your own bran. Point is, there are so many options if you're looking to eliminate this waste stream and make a beautiful, rich garden soil instead. If you have any questions or thoughts or things that I missed, as always, please leave those in the comments below. And if you want to see 7 different ways that you can try decomposing your Bokashi food scraps, you'll want to check out this video next. Thank you for watching, and we'll see you in the next one.